สวัสดีค่ะดิฉันนางสาววไลลผู้ช่วยรหัสนักศึกษา6200242สาขาวิศวกรรมเครื่องกลแผนกวิศวกรรมพลังงานวันนี้จะมาทำ 2D Transient Heat Transfer Analysis in Acid Workbench นะคะทำตัว Transient Heat Transfer ตรงฟินนะคะก็คือวาดฟินโดยมีข้อมูลนะคะคือดังภาพต่อไปนี้ดังนั้นนะคะเข้าโปรแกรม Workbench นะคะแล้วก็ลากตัวตรง Toolbox เนี่ยเลือกเป็นtransient thermal นะคะแล้วก็ตรง edit engineering data นะคะก็ใส่ข้อมูลเพิ่มเป็น new material ค่ะแล้วก็ใส่เป็นอลูมิเนียมโดยใส่ตัวdensity เข้าไป isotopic thermal conductivity แล้วก็ specific heat constant pressure นะคะโดยมีรายละเอียดก็คือ density ก็คือ 2,800 isotopic 170แล้วก็ specific heat ก็คือ 870หลังจากนั้นก็มาที่โปรเจกต์แล้วก็คลิกตรง geometry ให้มันเป็น analysis type เป็น 2D นะคะแล้วก็คลิกขวาแล้วก็เลือกเป็น edit geometry design modeler นะคะก็เข้ามาหน้านี้หลังจากนั้นนะคะก็สเก็ตโดยใช้ตรง polyline นะคะสเก็ตให้มันได้แบบนี้ก็คือติดตรงนี่ให้ได้รูปฟินแบบนี้นะคะจากนั้นไป modeling sketch concept surface from sketch
the concept surfaces from sketches and apply and then click on that surface on here and then invert that and now you can see that so that whole part is being generated. Next step is start model and for that one so this one you can save it. After saving you can close that one and then
model geometry material แล้วก็ assignment patin geometry material assignment ใส่เป็นอลูมิเนียม
here double click on model and show here starting mechanical of steps and assign that material. So for that one geometry to the surface body and material assignment is first received so you need to
geometry ถูกแล้ว
change it to aluminium. So now the new material for that surface body is aluminium. Next step, in the construction geometry, we create a path. So that path is required to put the temperature distribution along the center of the frame. So for that model, and then the construction geometry path. So that is the path, and it asks about that. What are the coordinates? So for that one, you click on coordinate system. That is right in the center. So then x-axis there is 0, 0 at the origin, and for that second one, x is 40 millimeter, and now you can see x-axis there is 0, 0 at the origin, and for that second one, x is 40 millimeter, and now you can see that. So that is a start, and that is the end of that path. Now remember that in the home you need to change the units here, and units you need to keep that the standard one. So temperature, here I'm using that Celsius, and then these are the units.
Okay.
So now you can see that there the path is created. So I am going to rename that as path. Let's say path 1. So that is number. By creating path, the number of sampling points is by default it is 47, but here the total length of the path is 40. So I am going to use it one less than that. That is 39. Next step is to perform mesh by a suitable mesh element size, and for that one you need to double click on mesh, and the default element size is something given. So I am that at it initial temperature, thermal transient, and then weight mesh. That mesh is being created. It's quite uniform. Next step in the set of thermal transient, apply initial temperature, and the initial temperature is 28. So here initial temperature, and it's a uniform temperature, and that is 28.
28.
Next step
Next step,
in the thermal transient,
environment,
environment
temperature,
and
it
the temperature boundary condition is for the case, which is 90, scope, geometry, edge definition, and then the magnitude of that. So that base temperature is 90, and for that one, again by clicking on the transient, either you can insert temperature there or go to environment and then temperature. And the temperature, click on temperature, it says scoping method geometry selection. So that is edge selection from here. Apply, and then the temperature here, the magnitude of that temperature is 90. In this way that temperature is being applied. Next step in the environment, apply convection, and the convection you transfer coefficient and temperature. So for all other edges, temperature is 28 and heat transfer coefficient is 30. So for that one, right click on that, go to environment, and then convection. And for that convection, you need to select these are the value, film coefficient is 30.
30.
And the temperature is 28, and then battery selection need to perform that.
Control.
Battery selection is very simple, just click the mouse and then just move that on the edges which you need to select. Okay, so all edges you can see they are green. So then apply.
Okay.
There are 15 edges selected. Now you can see that both boundary conditions are applied. Next step is in an analysis setting, number of steps equal to 120. So here in the thermal transient analysis setting, and then number of steps, I am going to use that 120 seconds for that. then rest I'm going to leave as it is. So now analysis setting initial temperature. So all these properties in the transient thermal are being. Next step in the solution setting, need to apply thermal temperature for the whole of that body and then thermal temperature along that path. For that one, scoping method path and path are required. So for that one, in the solution, click on the solution in the thermal temperature, so that temperature for the whole of the body. Otherwise, you can go here, insert thermal temperature, and this temperature too, I am going to make that temperature along the path. And for the scoping method is path, and then here is the path one. So now in the solution, that solution whatever are the required parameters, so they are done like the temperature along that path, and obviously that path end of the path is at the tip of the node, whatever the temperature is like. Guys, green tick on solution.
นี่ก็คือครับนะคะนี่ก็คือแม็กมินอนิเมะโอ้โหสำหรับคลิปนี้ก็ขอจบแต่เพียงเท่านี้นะคะขอบคุณค่ะ